Hello, this is Mr. Henry, and welcome to Lesson 5.2, Comparing Functions. The essential question says, how do I compare functions? So our warm-up, which is warm-up number 2, says, since functions can be represented in graphs, tables, and lists, how do you think we could compare functions? So go ahead and pause the video, put down your thoughts in warm-up number 2 on how you think we can compare functions. Okay, so you might have said some things like, well, since we can represent them as a graph, maybe we compare the position on the graph, we can compare the angle of the function. If you're talking about a table, maybe you look at very specific values to look at. So you're always comparing maybe when they have the x value of 0 or a y value of 0 to determine something about the graph. And those are the same sort of things we're actually going to do in this lesson. So we have here quite a bit of vocabulary words. So first one being rate of change, which should be familiar since we've talked about this in Module 4. Rate of change is a rate that describes how one quantity changes in relation to another quantity. In the past, we talked about like amount of work done per hour, or driving speed, or we even had a question like hot dogs eaten over an amount of time. Okay, slope is the formula m equals y2 minus y1 over x2 minus x1, and I have there that slope of a line is a rate of change. It is. So rate of change, when you're talking about a graph, the rate of change is the slope of that line. Okay, slope-intercept form is the form of a line y equals mx plus b, where m is the slope and b is the y-intercept. That should be familiar from the last module, along with at least a y-intercept, maybe not x as much. Y-intercept is the point at which a function crosses the y-axis, or I say not just a function, a relation, where the line crosses the y-axis. And then the x-intercept would just be the same thing, but for the x, it's a point at which the function crosses the x-axis. Okay, so these are all different ways we can compare functions. Now in this lesson, we'll be talking about strictly linear functions, functions of a straight line. And when you're talking about linear functions, you can talk about your slope and your intercept and your different things, x-intercepts, y-intercepts, all right, the equations of the lines, comparing them. So let's get into it. Example 1. It says here both relations represent linear functions. Okay, so we've got function A as a table, function B as an equation. Which function has a greater rate of change? Now, if you remember, rate of change is slope. So this guy we can tell by looking at the equation, this has a rate of change of -2. It's a slope. That's because this is in slope-intercept form, y equals mx plus b, slope, intercept. Okay, for function A though, we're just given a table. We have to find the slope from this, which we have done in the past. So what we did is we used our slope formula. y2 minus y1 over x2 minus x1. Pick 2 points, so I'm going to call this guy x1, y1, x2, y2. So when I plug in those 2 points into my function, what do we get? Well, we get 13 minus 9 over 4 minus 2 gives us, let's see, 13 minus 9 is 4. 4 minus 2 is 2, giving us a slope of 2. Okay, so function A has a slope of 2. Function B has a slope of -2. Which function has a greater rate of change? Well, it's got to be function A. Function A has a positive slope. Function B has a negative slope. So function A has the greater rate of change. Function A has the greater rate of change. Whoa, what was that? ER, greater rate of change. All right. Letter B. Luke graphed the function shown. All right, so we see his picture there. Nice. Leah wrote the function given by the equation y equals negative 2x plus 1. Which function has the greater y-intercept? Okay, so in this problem, we're comparing these two functions based off their y-intercepts. So I'm writing down my slope-intercept form again. So Leia, L-E-I-A, Leia's function has a y-intercept of 1. Okay, so her function would cross the y-axis at 1. Luke's function has a y-intercept of negative 2. His graph crosses the y-axis at negative 2. So based off the information that we're given, whose function has a greater y-intercept? Well, Leia's does. Leia's crosses at a positive 1. Luke's crosses at negative 2. Leia has the function with a greater y-intercept. Greater y-int. Leia's function has the greater y-intercept. Again, positive 1 compared with negative 2. So this function, this lesson so far is being about picking out the pieces of a function, the pieces of a linear equation from a table, from a graph, from an equation, and being able to compare parts. Okay? So example 2a, applications. And you're going to see this is where really the main part of the lesson is in these applications of comparing. So it says here, Morgan and Steve leave school at the same time. Both travel home at a constant speed. The table shows the function that models Morgan's trip home, and the graph shows the function that models Steve's trip home. And I have the graph on the next page here. Question is, who got home first? All right, so let's see. So time spent traveling. So when Morgan has traveled 0, she is 4 miles from home. All right. When she's traveled for 3 minutes, she's 2.8 miles from home. When she's traveled for 10 minutes, she's 0 miles from home. Okay, so when she's home, it took her 10 minutes. So based off of the table, we can determine it took Morgan 10 minutes to get home. See? 10 minutes, she's 0 miles away from home. That means she's standing at her front door. She's home in 10 minutes. All right. So what about Steve? Okay, so based off our graph, this is miles away from his house, time spent traveling. So at 0 minutes, he's 3 miles away, just kind of like Morgan was. Actually, Morgan was 4 miles away. And then he's going home at, 4 minutes. He is like 1.8 miles from home. 8 minutes, he's less than half a mile. And he gets home, it looks like roughly about 9 minutes. So I would say based on this graph, his distance away from home, 0. This is when he's at his house, is at 0. His distance away from home is 0 at a point of 9 minutes. So it took Steve 9 minutes to get home. And it took Morgan, 10 minutes, right? Yeah, it took Morgan 10 minutes to get home. Took 10 minutes to get home. Okay, so if Morgan took 10 minutes, Steve took 9 minutes, the question is who got home first? Well, then obviously Steve got home first. Steve got home a minute faster than Morgan. So Steve got home first by 1 minute. 9 minutes for Steve, 10 minutes for Morgan. Steve got home first. That wasn't too bad. It's being able to interpret your graph, reading the equations, reading the tables, and finding the information that you want. Being able to understand them. Letter B. Carlos and Lily are each painting identical walls for their painting service. Carlos has painted 300 feet and plans on painting 150 feet each hour to finish his wall. Okay, so that's Carlos's idea. Lily's plan for painting can be represented by the equation that, where x is the number of hours and y is the total amount of wall painted. Who is painting their section of wall faster? So the question is, who is painting faster? So when you're talking about the faster painter, you're talking about this rate of change, the rate at which they're working. Okay, so the key thing we're looking for here is our rate. We've got Carlos and we've got Lily. All right, so rate is how fast they're moving, how fast they're working. But we also talk about back in the vocabulary that slope of a line is a rate of change. So the slope is this rate. That's the thing that we want to be looking at. So slope and rate are the same. So based off Lily's equation, which was y equals 180x plus 20, her rate of change, her slope, was 180. Rate of change. So her slope rate of change is 180. That's how fast she's working based off her equation. Okay, Carlos, let's see, it says he has painted 300 feet of wall and plans on painting at 150 feet each hour, or feet squared each hour. So this, how much he's doing each hour, that is his speed that he's working. So he's working at a rate of 150 feet squared per hour. So he's working at a rate of 150. Lily's working at a rate of 180. Who is painting their section of wall faster? It's not hard now. It's got to be Lily. Lily's painting her section of wall faster because she has the greater rate of change. In case you're curious and you wanted to write Carlos's information as an equation, it would probably be this y equals 150x plus 300. This is the rate that he's working, and that's how much he already has done. So it says he has 300 feet painted, and he's continuing to work at this pace, and then the y variable would be the total amount of wall that's been painted. Just another way to show that his rate, his slope, is less than Lily's slope. All right, so here is letter C, something for you to try. I'll read it for you though. It says Donald is comparing two cell phone plans that charge by month. Let X represent the number of minutes used over 500, and Y represent the total cost in dollars. The cost from AT&T is represented by the equation, and there it is in blue. You'll need to put that on your paper. Y equals 0.35x plus 20. The cost for Verizon is represented by the graph, and the graph is shown below there. Which plan charges more per minute over the 500 minutes that are included? Okay, so which plan charges more per minute over that 500 minutes are included in the plan? Go ahead, pause the video. When you're ready to continue, hit play, and we'll go through it together. All right, so the cost per minute, that's a rate. If something is happening over time, that's a rate. So like work done over time or painting done over time, So what we're comparing here is which plan charges more per minute over the 500 minutes that are included. We're trying to find out what is the rate of change. Okay, so AT&T has this equation, y equals 0.35x plus 20. So they're going to charge you 35 cents, or what I'm interpreting, they're going to charge you 35 cents per minute, because x is the number of minutes, and then y would be the total cost. So they're going to charge you 35 cents per minute. Okay, and then this equation gives you their total cost. Let's check out Verizon based off the graph. So the number of minutes, so they're going to start off at $15, and then after you've used like 2 extra minutes, your cost is there. After 4 minutes, your cost is there. 6 minutes, your cost is there. 8 minutes, your cost is there. Okay, so to figure out the greater cost per minute here, we have to find out what is this cost per. We have to find the slope, the rate of change of this equation. You could use the counting box method here. Just make sure you're paying attention to your scale. So, I mean, if I'm going from example, I like this point here and this point here. So if I'm going to be counting boxes, no, you're not just going to go up 2 over 1, 2, 3, 4. It's not up 2 over 4 because the change from here to there, you're going up 5 from 15 to 20. Up 5 and over how much? Well, from there to there, you're going from 0 to 4. So you're going up 5 over 4. So the slope of this line is up 5 over 4. Well, what would that be as a decimal so we can compare our cost per minute? Well, let's see. So if we take 5 divided by 4 equals 1.25. 1.25. That is the slope of this line. So the rate of change, this company, I guess is what, Verizon, they would charge $1.25 per minute that you've used after that 500 minutes, where AT&T is charging you 35 cents per minute after that 500 minutes. Which plan charges more per minute over the 500 minutes that are included? Well, according to this data, this would be Verizon charges a lot more per minute. Now, just to say, these numbers are all made up just for the problem, so don't go switching your cell phone plan because Mr. Henry said Verizon charged you so much extra. But according to the data here, Verizon charges more per minute than AT&T. All right. I think we're ready for our summary. So summary says, when comparing two functions, what are some possible criteria? What are some things that we compared functions with using today? Go ahead and pause the video. You're ready to continue, hit play. We'll go through it together. So here's my answer. It's fairly small. It says, we can compare functions using slope, rate of change, y-intercept, and x-intercept. And remember, slope and rate of change are the same thing, just different contexts. Okay. So those are the ways that we compared functions throughout the lesson today. This has been lesson 5.2. Thank you for watching. Goodbye.